Hello everyone. So, here's this week's handout, Solving Systems with Substitution, a sort of new topic. The original example video should give you enough information to think about how to solve 1 and 2. Number 3 looks a little different, and I've gotten some questions about that. So here, instead of having both equations in the form y equals mx plus b, we have one equation in that form, but the other equation is not in that form. And the point remains the same, that you'll basically have an equation, that you'll basically have a system of equations that'll look something like this, and there will be a point where the two lines intersect, and that'll be the solution. Okay? And we're going to look for that without graphing it. And the key step here involved taking the y value from one equation, okay, and inserting or substituting that y value into the other equation. All right, so I'm going to show that step now. So I'm going to take my top equation, 8x plus 2y equals 8. But instead of writing it the way it was originally written, where y just is y, I'm going to take the value of y from the other equation, and I'm going to substitute in that value of y from the other equation into the top equation. So I've taken the top equation, 8x plus 2y equals 8, and I've taken the y value from the bottom equation, and I've substituted in that y value from the bottom equation to replace the variable y in the top equation. Now this is just a single variable equation that I can solve for x now, because there's no y left over here. The key thing about substitution is it allows me to transform this top equation from a two-variable equation with x and y into a single variable equation with only x's in it, and this y has been completely erased and replaced with an expression that just has x in it now. And I can solve this equation here. The first thing I'm going to want to do is clean up this left side and combine all my like terms. And in order to do that, I'll have to apply the distributive property. So I'm going to get 2 times negative 6x plus 2 times 2 equals 8. So all I did here was multiply the 2 by everything in the parentheses using the distributive property. And then I'll clean that up. Then I'll combine my like terms here. Positive 8x and negative 12x comes to a total of negative 4x. Okay? And now, I have some strategies for this. I'll subtract 4 from both sides and divide both sides by negative 4. X is equal to negative 1. This is part of my solution. That would tell me, for instance, if you look over here, that I know the x value for the x-coordinate for that point. But I only know the x part of the solution. I don't know the y part of the solution yet. A solution to a two-variable equation, or a solution to a system of two-variable equations, needs to have two different numbers. Not just the x value, but also the y value. So we've got the x value so far, we need to figure out the y value. Okay? In order to do that, I'll take this purple equation, y equals negative 6x plus 2, and I'm going to say, hey, I know that x in the solution should be equal to negative 1. So I'll replace the variable x with the number negative 1. And negative 6 times negative 1 gives positive 6. And positive 6 plus 2 is 8. And so what happens when I do that is I substitute in order to get a single variable equation. I figure out what x has to be equal to in my solution, and I use that part of the solution to figure out the other part, which is the y value. Together, my whole solution is the ordered pair, negative 1, 8. That's my whole solution together. And I would like now to demonstrate how you can check that so we can understand what exactly we found here. Okay, here's my check. What we found is that if you take the top equation, 8x plus 2y equals 8, and you substitute in this ordered pair, negative 1 for x and 8 for y, then on the left-hand side you get 8 times negative 1, which is negative 8, plus 2 times 8, which is 16, equals 8. So the left becomes 8, and the right becomes 8. So the top equation is solved by this ordered pair here. The bottom equation is y is equal to negative 6x plus 2. And if you replace the letter y with the number 8 and the letter x with the number 1, on the left you get 8, and on the right you get negative times negative is positive, and 8 equals 6 plus 2, which is also 8. So both equations are satisfied by this ordered pair, and that represents the one place on the curves where they have the same point, the point of intersection between the two lines. That's what a solution to a system of equations looks like on a graph, and now we have a new way to find it without graphing at all.